you can live and work close to close. Walkways, bikeways, and parkways. Now, this is a little bit of a challenge because we do have winter, so how do we get people to continue to participate in active transportation when it's freezing rain or cold? It's a problem. Georgina was saying she doesn't like winter, it's cold, and I'm saying this isn't cold. But that's another discussion, and I'm going to talk a little bit about how we actually manage our infrastructure. So the first area is really looking at our virgin material usage. So we want to be trying to reduce the need for non-renewable resources. So in other words, geologically, there's aggregate in the ground or at a quarry, or we get it from different places, but that's a non-renewable resource, okay? It's not everywhere, it's not good quality, so how do we manage that? The materials can be expensive. Really what we're looking at, good utilization. So if we're building the main runway out at Atlanta Airport, we're going to use premium aggregate, right? We want good aggregates, so when that A380 comes in, screaming in, we're providing a high friction surface. On the street that you guys live on, not so much, right? We don't need to supply that high friction durable material to the same extent. And the idea is how can we actually make more use of recycling? Looking at alternative materials, so the opportunity to recycle. So this would be, and see, this is an American picture, American penny, I put that in for you guys. So we basically have our materials, okay? We've got the asphalt cement here, or binder, and then we've got wrap. So can we actually replace some of this material here with that recycled material? Okay, and if we're going to do that, how do we do that in a smart, engineered sense? We can also put things like recycled tires. We can look at recycled aggregate and so on. But if we're going to change the way we design our infrastructure, then we need to evaluate it. So a lot of our work is actually building smart roads or instrumented roads. So what I have here is some different types of instrumentation. So in the upper corner is what we call an earth pressure cell. And basically it's a plate, and we put it way, way down in the infrastructure, down in the soil. And we put those in areas, we've got a bunch of them at Toronto Airport. So right where the heaviest aircrafts park, at Toronto Airport, we have these gauges way, way down. And we're evaluating what impact that has on the infrastructure. This is a moisture probe. We use different kind of moisture probes. We put them at 2 elevations. And we'll have an environmental station, and it starts raining. And what we actually do is we track how long it takes for the water to go through, hit the first moisture probe, how long it takes to get to the bottom one, and how long it takes to dry. Again, why would we do that? Well, we want to track the health of that structure, and we know that if the water is trapped in there, it's going to degrade over time. Okay? We have strain gauges. So this is a concrete strain gauge that we actually build on a chair. This is an asphalt strain gauge that we typically will put right either on, well, I've got a picture of actually installing. And basically the strain gauge expands and contracts. Okay, it expands and contracts related to temperature, but it also expands and contracts related to what's on top of it. So again, if I park a heavy truck or a car or an aircraft, it will show in the strain gauge. And what we know over time is that so much performance, this expansion and contraction, at a certain point, if the pressure exceeds the strength, what's going to happen? Yeah, say it loud.
It's going to fail.
It's going to fail. It's going to crack. The bottom picture, we actually bore a hole in the pavement structure, and each one of those little black marks is a thermistor, and it measures temperature. So we track freezing and thawing. So again, we track how long it takes for it to freeze and how long it takes to thaw. Okay, so we use all that information. We've instrumented the structure. And we look at differences in materials, we look at innovative tools to measure performance, so safety, smoothness, distress, structure. We assess the impact of environment and traffic on performance, and we use that information to provide better designs. So the information that has come out of Toronto Airport has actually impacted the way we design airports across Canada, because we show what kind of damage is happening when we park those Code F, those Boeing 777s and those A380s on top of those strain gauges so that it's changing design. And then of course, we're taking that information and moving it to the field. We do a lot of lab work too, so here in the lab, and you saw some pictures where we test different materials. This is an environmental chamber, so basically we have linear transducers on here and we load it, so we simulate loading of heavy vehicles, fast vehicles, slow vehicles, so we test at different frequencies and different temperatures. This is the chamber to see how it performs. That over there on the right is a lab absorption tool. So there's a lot of pressure in cities now to build the pavement that absorbs noise. Why is that? Because we don't want to have those ugly noise barriers. They're expensive, they're hard to maintain, there's a lot of graffiti cleanup, there's a lot of issues. So that device on the right actually helps tell us about infrastructure. We have a full-scale test track where we have different materials. I'm not going to get into details, but you can see the middle one, that's shingles, roofing shingles, so demolished shingles that we've actually ground up and incorporated into the asphalt pavement, and they're performing really well. So what's the advantage there from a sustainability? Well, that stuff used to end up in the landfill. We're actually grinding it up and incorporating it into the pavement. Now the challenge with this material is it's very stiff. So if you put too much in, it's going to make it so stiff that it cracks. So the idea is that you put enough in to make it durable, but not crack. So again, this is the strain gauge going in. So this is actually on the Trans-Canada Highway. So if you stayed on this highway, this takes you to Windsor-Detroit border crossing, which is one of the busiest border crossings. So into Canada, the 3 busiest border crossings are all located in Ontario. Windsor, Detroit, Sarnia, Port Huron, Michigan, and Niagara Falls. So again, monitoring, tracking, doing different types of lab work. So we have quite a number of grad students that are looking at different types of innovative products. We're using things like warm asphalt. So basically, you're not heating the pavement, the hot mix materials up to as high a temperature. So that has lower emissions, so it's better for the environment, it's better for your workers. And it also allows longer hauls. We're also doing some work on porous asphalt, and so obviously it has excellent potential for parking lots. It's a structural and hydrological design. And of course, both of these tools are assisting with some of the changes that we were talking about earlier. Higher temperatures, more moisture, and so on. Okay, so there's just some close-ups of the material. Okay, so coming back to the idea of aggregate, this is a really important issue for us as civil engineers, because what's happening worldwide is the high-quality aggregate close to urban sources is really scarce, and that's where we need it. Shortages may be experienced in 10 to 20 years if new licenses aren't approved. And what I'm hearing is very similar in Canada and the US. A lot of cities and a lot of state DOTs are not allowing new pits and quarries to open up for environmental reasons. So what that means is we don't have sources. So this is a problem. We're getting into what we call resource efficiency, so maximizing where we use materials. And this is coming back to recycling. So if we are rehabilitating a road, or we're ripping down a bridge, we're demolishing a bridge, we're actually taking that material and crushing it and actually reincorporating it. So we're basically looking at aggregate reserves, we're looking at long haul alternatives. So in the province that I live in, basically we are going to require the use of rail or barge, so bring it down on boat or rail to bring a lot of the aggregate in. And socially and environmentally, that's not acceptable. Okay, we're creating, if we're having to truck that aggregate literally thousands of kilometers, what kind of impact is that going to have on the environment? We have more vehicles on the road, right? More emissions. Okay, so lots of issues. So there's some serious consequences. And just an interesting statistic, in 1994, when I was in the design office, and we used to do cost estimating on projects, we used to figure that 2/3 of the cost was related to material and 1/3 was transportation. Now it's flipped. So 2/3 of the cost. So if you're going to spend $1,000 on aggregate, you know, $666 is related to transportation and $333 is the aggregate, where it used to be opposite, okay? And so this is having a huge push for us to look at alternative mechanisms.
Just one thing.
Yeah.
So the transportation referred to carry that material from one location to the other?
Yes.
Okay.
Yeah. So that's the cost where we have to extract it from a quarry or a pit, depending on the source, that we're spending a large amount now transporting it to the job site, where it used to be the flip. So we're doing a lot on demand management, looking at changes in urban design and greater recycling. We're looking at, so one of the challenges, the lack of data, but what we do know is that we have to better manage it. So our team is working with departments of transportation across Canada to look at smart growth principles. So if we're going to grow and we're going to expand, how do we do that in a better way? And then of course looking at the different types of materials. Okay, here was an example. So this is actually a recycled asphalt pavement stockpile. This was an open house. All those white hats are supervisors from the ministry, from the DOT, from different municipalities and cities. And actually this particular contractor that we work closely with has a very good setup of processing and reincorporating it. One point I want to make here is we don't want to build a linear landfill. Okay, so the idea is we don't want to put garbage in the road. What we want to do is engineer it. Okay, so we want to test it, evaluate it, and then add it in appropriately. Okay, that's important. So if we're going to recycle asphalt, there's a lot of savings, so non-renewable aggregate. It reduces the CO2 emissions. You're looking at 10 to 30% energy savings in all of the aspects of construction. So that's production, transportation, placement, compared to the energy required to actually extract it from the ground. Recycled materials have been shown to perform equal and in some cases superior. Because when we first built that road, or if we're looking at recycled concrete, we've taken bridges out off the main Trans-Canada Highway, and the concrete aggregate that comes out of that is equivalent to premium aggregate. Why is that? Well, 50 years ago when they built the bridge, they used good quality aggregate, right? So that good quality aggregate hasn't changed, you know, and so, but there are some things that we need to think about. And so for you guys, you know, many of you will go to work for contractors or consultants, so what we need to do is think about managing. So maintaining those recycled asphalt pavement stockpiles separated by source. So in Ontario, we have a very sophisticated system. If it comes off, you know, if it comes off the runway at Toronto Airport, it's in a premium pile. If it comes off the Trans-Canada Highway, it's in a premium pile. If it comes off a secondary or collector it goes in another pile. So in other words, we're managing. We're fractionating that, and we're crushing it. So that picture down in the right corner shows you what's capable if proper tools. Another big part of the work that we've been doing is looking at recycled concrete. So one of my PhDs worked extensively in the lab to develop some mixed designs, and then we placed at our test track jointed plain concrete pavement with dowel bars with varying percentages of recycled concrete aggregate. And again, it's good quality aggregate, and we're basically saving using the virgin aggregate. We've also done a lot of work related to this idea of sustainability, where we have 4 test sections. Well, this is our control of our local aggregate, our control mix. We have a stone mastic asphalt, which is the best asphalt. You place it here in Georgia. High quality premium aggregate. We've got a rubberized open friction course, which you also place here in Georgia. And the rubber comes from recycled tires. So we've recycled tires, put it in. And then we have a rubberized open graded course. So these two are identical except for the aggregate. Okay, so this one's premium. It had to be trucked in farther, more expensive, versus the local. And we monitored this test section for 10 years. And the winner here was the rubberized open graded course. So it provided value in terms of performance and also in terms of noise. So again, why is this of interest? Well, because all of the cities in southern Ontario are using this now, and they're not placing those expensive noise barriers. Okay, so again, it's about innovation. We're looking at recycled concrete in a bunch of different spots. So again, this is being driven in part by environmental regulations. We're taking concrete, we're crushing it up, and then we're stockpiling it, and then adding it appropriate. Here's some different examples. So this is pervious concrete. We've done a lot of work. We've produced a Canadian guide on pervious concrete. So you can see the pervious concrete, and this is actually, this is a red concrete, conventional, for architectural purposes. So again, we're working with a lot of architects to, provide stormwater management through the use of the pervious concrete, but also making it look nice with different colors. The middle photo is a fast-track concrete repair at Toronto Airport. And then just some different types of testing. In the bottom corner, you can see 2 different types of recycled aggregate. You can see the old stone and the mortar for structural applications. So again, as an engineer, if you're going to go out and build a bridge, there's often skepticism about using recycled materials because you want to make sure they're high quality. And so a lot of the work that we've been involved with, actually my student that did this is now at Cambridge doing a postdoc. And what we actually demonstrated here is that recycled concrete can be used for structural applications, but again, it's got to be premium aggregate. There's some of those chairs that we actually build these chairs so we can install the strain gauges. So again, different applications. This is Vancouver, British Columbia, and this is the entrance to a concrete plant, so lots of heavy trucks use this. So the trucks come in, and then what we've got here on the side is the pervious concrete. So again, the idea is that it provides very quick drainage. In that particular location, lots of rain. So all of this work kind of has led to quite a big change in the way that we value sustainability in the province of Ontario. And what you have in front of you is a point system, which I guess is somewhat similar to LEED. And what we have worked closely with the DOT is to come up with a rating system for pavement, and it's now being modified for bridges, where we look at different things that we can do as a designer to promote sustainability. So there's pavement technology, so long life designs, permeable pavements, so that pervious concrete, Quiet pavements, so again, that open texture, it helps absorb noise. Cool pavements, we don't build a lot of cool pavements, we don't need cool pavements, but we've been doing some advisory work for some of the folks in California, where, if you have high temperatures in the summer, actually in Japan, interestingly enough, they build pervious concrete and they put water in it in the urban areas, and then in the summer, the water actually evaporates and it lowers the heat island temperatures. You'll see, look at on the Ontario recycled content. So if you're using recycled materials, you're getting a pretty big premium. Local materials, again, and reuse, and so on. So this system that we've helped develop has been quite instrumental, because if I put a design forward, and Georgina puts a design forward, and let's say my design has recycled content and is long life and has some of these and meets some of this criteria, I'm going to get credit. And she's old school, she worked for the DOT for years and years, I'll be teasing her. And she presents a design that's sort of conventional. She's not going to get that. So it's been a great tool for us, and we've been directly involved in that. And the idea here is that when we're designing infrastructure, we want to think about the whole life. Okay, from planning and programming to end of service. And you can see here, how we actually deal with it at the end of the service life. We're thinking about managing that infrastructure, so at different phases of the land